All right, guys, here we go. So nobody joined for the third period Zoom this morning either. So this is for third period and fourth period biology, and hopefully this helps you guys out. You guys, this is how we're going to keep moving on with class. This is what we're going to do right here. So we finished with section 2, talking about those energy diagrams whenever we were here. Started working on all that work, and now I want to move on with chapter 6, section 3, and this is all on water and solutions. And don't worry, I'll be sending you this as well, this PowerPoint, so that you'll have it for notes wise. So let's just jump in and get started. I can figure out how to make it work. There we go. All right. So in this, first thing we're going to talk about is water's polarity. So we talked about this before, and whenever we was discussing it, talking about water, I talked about how there's that partial positive and that partial negative. So you can see here, like they're labeling out these slightly positive ends, and this here and that is the hydrogens. All right, that's in water. So H2O. So these are your hydrogens that you're looking at. And what happens is oxygen, which is this big guy down here, has a greater pull on those electrons. So what happens is he pulls on those electrons more than the hydrogens do. So what happens is it's like that electron's not really there a lot of times with that hydrogen, which makes him slightly positive. And that means that those two electrons are down there with that oxygen more, so it makes him slightly negative. So what happens is we'll get like a partial positive, partial negative sides and areas to this molecule, which you know what opposites do, opposites attract. And this all comes from and is a characteristic of covalent bonds. Okay, you have what we're really talking about is a polar covalent bond right here. And what happens is that when all that electron, when those electrons that are supposed to be shared are getting pulled more, then what takes place is you'll form that slightly negative and slightly positive areas. And what happens is those water molecules will line up, and it's going to show like special properties of water that we're going to talk about here in a minute. So this is really takes place in molecules that are uneven distribution in charges. They're what we're called polar molecules because they have polar covalent bonds formed in them, and that just means that they have opposite charged regions. Okay. So within this is the really cool thing, and this is one of those big things uh, that today what we'll do is whenever you look at it is um, the polarity gives this special property to water to form something that's called a hydrogen bond. And all the hydrogen bond is it's a weak interaction. It's like a weak bond between molecules involving hydrogen atoms. And the key to it is it has to involve not another highly electronegative element. For examples, though, it's fluorine, oxygen, nitrogen. They don't include this one on there, but chlorine's another good one. And all hydrogen bonds is, if you guys remember, we talked about those van der Waals forces. And that's what I said. Really, I didn't like the example they used for that van der Waals force because it really was a hydrogen bond. And hydrogen bonds is the strongest type of van der Waals force you'll get. That is why you see, and we get all these special properties with water. Every property you see within water, it comes because of these hydrogen bonds. All right. Oh, then we got this of mixtures with water. So you guys, you've seen mixtures before. Don't make it like something really complex in your mind. Mixture can practically be anything. Just two things being mixed together. We technically have a mixture, but you can do that with more things as well. Like you see here, it's just a combination of two or more substances in which each substance retains its individual characteristics and properties. So what that's saying is you mix some things together and a chemical reaction didn't take place. Those things still are separate. So um, it's like one thing we're going to talk about is salad dressings. Okay, so whenever you look at it, you got those salad dressings in there. Are great examples of mixtures. So in this, you have two different types of mixtures that we're really going to talk about. And the first one of these are homogeneous, and the second one are heterogeneous. Okay, so in those two are two different types of mixtures that we're going to talk about and look at here. So first one we're going to talk about is this homogeneous mixture. So within this, homogeneous mixtures is just that mixture that's uniform throughout. So what I'm saying, okay, so think about there's the two different types of salad dressings that I'm gonna use is ranch and Italian. Okay. I love Italian salad dressing. I love it. That's my type of salad dressing. Now my wife on the other hand, she likes Italian, but she likes ranch. Like my wife is one of those people that, and maybe you are, that she'll get a slice of pizza and she'll put ranch on it. And I'm like, ooh, that's disgusting and gross. What are you doing? Um, but in that ranch is like a homogeneous mixture. Because think about it, you don't have to shake it up, do you? It'll stay separated out. Everything will stay the same all throughout the bottle of ranch. Okay, you don't have to shake it up. Think about Italian. If I take Italian salad dressing and I just set it for 10 minutes, everything separates out. If you don't believe me, next time you're at Goodson's or whatever grocery store you go to, and you walk down the salad dressings, look at Italian that's been sitting on the shelf. You can clearly see it separated out. You can see every different layer, and you're like, oh my gosh, all that stuff's in there. What is all that stuff? You can see everything separate out. That's what I'm talking about. But in this case, we're talking about that homogeneous mixture. Okay, so that homogeneous mixture, all this is just a solution, and all that is another name for a homogeneous mixture. That solution that's made of a solvent and a solute. Okay, now heterogeneuses are also made of solvents and solutes, but it's different. Okay, they can separate out. But these solvents and solutes, the solvent is just like you see here. It's the substance in which another substance is dissolved. So it's kind of the thing that like takes it in and spreads it out. And then a solute is the substance that is dissolved in the solvent. Okay, that's really big and really important. So we use those a lot. If I ever get to teach AP chemistry here, you'll be seeing, if you decide to take it, you'll hear those two words big time. Because you got to know what the solvent is, you got to know what the solute is. All right. So that's what a homogeneous mixture is. Remember, homogeneous mixture, everything's the same throughout, doesn't change. Heterogeneous. So we have heterogeneous mixtures. So heterogeneous mixtures, this is when the components in a mixture, they remain distinct. Okay, they are not evenly mixed together. In these, this is what I'm talking about with like an Italian salad dressing. We can shake that bad boy up, pour it on our salads, and it's like, it's good. Or I recommend one thing I like to do with it is I'll marinate chicken in it every once in a while before I throw it on the grill. Or whenever I do kebabs, what I'll do with the kebabs is um, I'll actually baste it like every minute in Italian dressing. It is so good. I highly encourage, if you like grilling chicken, get you some Italian salad dressing and you will not regret it. But in this, we have a suspension, and this is just a type of heterogeneous mixture where the particles settle out over time. That's that Italian dressing. I'm telling you. Walk down the aisle next time. You walk down the aisle and you look and you're like, oh my gosh, look at that Italian dressing. That is not good. That has spoiled. No, it hasn't spoiled. What has happened is that it's just separated out. Okay, and that's based off of densities and things, and they don't want to mix together and the different types of bonds that's in them and stuff. It's it's hard. Okay, so like in it, we talked about like ionic and covalent bonds. But within it, what you'll see is it really is based off that covalent bond, if it's a polar or non-polar. In that case, like things will mix together. So non-polar and non-polar will mix evenly together, but polar and non-polar, they won't mix evenly together because there's charges and everything interfere with each other. You can get polar and polar, and they'll mix together really well. Uh, Later on in this class, something we're going to talk about, we're really going to focus in on is that plasma membrane, like one of those papers I had you write. And in that, it uses that, it's literally just based off that special properties right there. It's such a simplistic idea, but it works to perfection so well, and we're going to talk about it later on. And yeah, so you do have some heterogeneous mixtures that don't separate out, and those are coiled, uh, so that you have that. All right, so within this, something else we have is acids and bases, and this is really where, like in AP chemistry, I would really focus a lot within these mixtures and solvents and solutes and everything going on, because what you'll see with it, acids and bases are very special types of chemicals. And I'm going to break it down very simplistic in this class for you. Pretty much an acid is a solution that just releases out hydrogen. Okay, so what it's saying here is this hydrogen ion, that's H plus. If you're interested in it, that's actually technically a proton, and we just call it protonation. But uh, in it, it pretty much, you're just saying you kick hydrogen out and say peace out, home dog. In it, bases are opposite. Bases will kick out hydroxide. Okay, and that's what this is right here. This is hydroxide. And hydroxide that's what we find within base solutions. So an example of something that's basic are like soaps and things. So soaps are very basic, and we use those to make ourselves all clean and smell nice and fragrance and enjoyable. Hopefully you took you a shower today. Some of you probably are not out of bed yet, which is why you are not on the Zoom. Okay, watch for the Zoom links. Read your messages on live grades. All right, then um, within this is just showing like here. So like this is an example. So like here's some acid, and then when it like comes in contact with water, it releases off those hydrogen ions, which you see there. And here's a base, a substance with a hydrogen ion, and it just releases it out. So that's literally how we get how basic or acidic something is. We look at how much hydrogen ions or how much hydroxide ions are within that solution, and that's what's going to tell us whether it's acidic or whether it's basic. All right. So here's, for example, like what I was talking about, like down here. See if I can move me. There we go. Move me out of your way. So like here is an example. So this is like a pH values here, and 7 is neutral, and that's pretty much like where you find pure water. 100% pure water is basic, is not basic or acidic. It's neutral at 7. And in here, I'm really not huge on this, like this blood, because actually your pH level of your blood is sitting somewhere between 7.35 and 7.45. The body tries to keep it right at 7.4, and that's where like the body is so concerned with keeping everything the way it's supposed to be. And this is important because the environments that you find things in will dictate if it works properly or not properly. Okay? So a good example of this is your blood, for example. If something happens and you drop it and it goes into more basic, then it'll try and correct it. If you raise it and it goes towards acidic, it'll try and drop it. It tries and keeps it between that range because that's the range where everything is healthy. Now, a great way to do this is a special type of mixture with water. It's called a buffer. We use it um, within chemistry to keep certain pH levels within a solution. So buffers are special because those have hydrogen ions and hydroxide ions, and it's literally that thing is built to just keep it. Like if I added something acidic, it'll take those hydrogen ions and it'll keep it where it needs to be. If I add something basic, it'll take those hydrogen ions and keep it where it needs to be. It won't allow it to switch off. It'll stay where it's supposed to be. All right, so the amount of hydrogen or hydroxide ions, that's what determines the strength of an acid or a base. So like something you get here is like your stomach acid's a really good strong acid. Battery acid, I'm pretty sure that's sulfuric acid if I remember correctly, and that is actually one of the 7 strong acids. So is hydrochloric acid, which is like your stomach acid, for example. Then you start getting into weaker acids like lemon juice, vinegar. Like vinegar has acetic acid in it. It's really good for cleaning, but that's about it. And then you have the measure of concentration of that hydrogen ion. That's called the pH. Okay. Then you can also flip that for a concentration of hydroxide ions and find pOH. But pretty much what we focus on is the pH scale. So acids will have a value that's less than 7. Bases have a pH value that's greater than 7. Remember, 7's that midpoint. All right. And keeping in mind, so 0 to 7, acidic. 7 up, basic. All right. And remember that 7 is not really acidic or basic, it's neutral. So then we have buffers that are mixtures that can react with acids or bases to keep the pH within a particular range. And that's all I'm saying with this is within those, what you'll see is that buffer just works to keep the pH level where it needs to be. That's all it does. Okay. It's a very special type of mixture that we like to use. All right. So that is the end of section 3, and that was literally it today. So this is what I'm gonna do. This is being sent out to you guys. So hopefully you've watched this. If you have any questions, reach out to me. I am working my hardest at trying to get your grades put in. Uh, do not freak out. Okay, I can't stress this enough. Do not freak out. This is only the first 9 weeks. This is not the final grade. This is not what is set. All right, you'll have the semester grade, and that is what's set. Not the first 9 weeks. Grades keep going on from here. All right. Have any questions though? Reach out to me. If not, peace, y'all.